So hi everyone, this is Kenneth and this will be my exam 5 video submission for the Sudoku Solver project. I'll be showing and explaining every single line of my code while walking through how it works from start to finish. So first let's look at the puzzle that we're solving. This is a 9x9 Sudoku grid. The rules are that every row, every column, and each of the 9 3x3 boxes must contain all the numbers from 1 through 9 with no duplicates. Any cells with zeros are considered blanks that need to be filled. So this is our 9x9 board. And as you can see here, this is a 2D array store that stores the unsolved puzzle directly as a matrix. I use 0 to represent the blank spaces, and this matches exactly with what the diagram provided in the assignment. So if we go back up, I'll be going over the overview of the structure. So my program uses a recursive backtracking algorithm to solve the puzzle, and then I'll be walking through the functions one by one. So first we have print board, which will be right here. So this function prints the board in a clean, readable format. I added vertical dividers after every 3 columns and horizontal dividers after every 3 rows to clearly represent the 9 3x3 subgrids. So this makes it easier to verify the output visually. And then I also added constraint checkers, which are is in row, is in column, and then is in box. So first, is in row checks if a number already exists in the current row. That'll be right here. And then we have is in column. So this checks if it exists in the current column. And then we have is in box right here. So this just checks the 3x3 grid that cells belong to. So they return true if the number is already present and false otherwise. And then we also have is safe right here. So this function combines the 3 checks I just mentioned. It returns true only if the number is not already in the row, column, or box. And that's how we make sure every move follows the rules of Sudoku. So here we end to our backtracking. So we have solve Sudoku. So this is the recursive backtracking function that drives the entire solver. It loops through the entire grid and looks for an empty cell at 0. And then once it finds one, it tries all numbers from 1 to 9 in that spot. So for each number, it calls is safe to see if it's valid to place there. If the number is valid, it temporarily places it and makes a recursive call to try to solve the rest of the board from that state. If that call leads to a dead end, meaning no solution exists for that setup, it backtracks by resetting that cell to 0 and trying the next number. If all numbers from 1 to 9 fail for a cell, it returns false, which signals the previous call to backtrack again. This continues until the puzzle is completely solved or it's determined that no solution exists. So this is my function right here, the solve Sudoku. And then we also end with our initializing our main. So finally, this is the main function that sets everything in motion. We start by printing the unsolved puzzle using printboard, and then we call solve Sudoku. If the solver returns true, that means the puzzle was solved successfully, and we print the solved board. Otherwise, we display a message saying that no solution exists right here. So we have unsolved Sudoku puzzle, then we have solved Sudoku puzzle, and then no solution exists. So then now we can run our code to see if we have a solved puzzle or not. So when we do run it, it first displays the unsolved puzzle, right? So each 0 is what we're trying to solve for. These are the different numbers that we're looking for. And then it also provides our solved Sudoku puzzle. So every single space is filled. That means that it did solve. And this should also match what the puzzle is given on the assignment itself. So yeah, that's about it. Thank you for listening.